We are in the field for this little update. I'm washing some clothes down here in the basement. And if you have one of these, if you know what this is, then you know how important it is that it does not overflow. Yeah, some of the plumbing running into this tank, this underground, in-ground, in the basement, they call it a sump. Some of the water running in there is pretty nasty. We flush our toilets into it on the basement level here. Now the way this thing works, it's about 1 meter, maybe a little more deep, and as big around as that hole there. So let's see, I'm gonna put my sandal foot over there to give you a sense of scale. And there's a pump in the bottom of that thing. It's plugged in here, right? And there's a float switch down in there. And when that float switch when enough water gets in there to push the float up far enough, the pump runs. And it pushes the water up this pipe and through this check valve. This check valve right here will not let it flow back down. And then the water is standing right now in this pipe, right? Going up here. And then there's like, well, it goes up and over, and then it ends up running out the sewer. So the water that gets up above that level right there will flow out through the sewage system. Yeah. Washing machine is running right now. So it should pump some water out here in a minute. So this is bringing us to our project, this little sump pump monitor. User interface is, clunky and probably needs some improvement. I could do a good bit of improvement, but I think that what this video is about is the concept. And the use of this thing. This is it's a transducer that sends out, and there's the black wires running down here, and I've got it shoved up underneath. It's right there. It's right there. I've got this paint can sitting on top of it to hold it in place. This black thing right here. It's an ultrasonic distance sensor, right? And it will sense distances. Well, the reading we have here is supposed to be the distance in centimeters. It'll sense distances from like, I think 20 centimeters up to like 1.5 meters or something like that. I'm not sure exactly what the range is. It's the one that's not, there's a couple, there's a few of these sensors out there. This is the one that's not terribly accurate at extremely short range, but it has a little more range than the other ones. And I was wondering if I need something to monitor this sump, because it has overflowed on me and it's not nice. So when that happens, this thing, the goal here is to monitor the capacity. Now so the green line there is not the water level, right? The green line, or the green scrolling, is the capacity level. That's the amount of capacity in this tank. So our sensor is measuring the distance from, right, the top of the tank down to the water level. And I'm going to pause here, and I'm going to wait for the washing machine to start doing something to make it move around. Okay, the game is afoot. That noise is, I think, the washing machine running water out, pushing water out. Oh, that thump you heard right there was the sump pump running. So yeah, the sump pump. And we're getting some strength. We're getting all kinds of variation. I think. So this is a very volatile time, right? There's a lot of water running into the pump, a lot of water running into the sump. You can hear it down there. You can see it coming up, but there's also quite a bit of noise in it, right? There's turbulence. That is the alarm going off, letting us know that the water level has gotten too high. I've got it set, I've got the threshold set pretty, there goes the sump. Hear the pump? The pump run, you hear a thump here in a minute. That thump right there is the sump shutting off and the back pressure coming down this pipe and hitting this check valve. So imagine, right, it's pushing, and then it stops pushing and the water flows back and the check valve closes and it makes that thump. All right, so there, now we see that hump right there in the graph. That's where the water, the washing machine caused the water to go up, and then the sump pump ran it back down. So I think it's, yeah, it's running some more. It's pushing more water out. I can hear it. Actually, it's spinning. I think the main surge of water is over with. It will push some more in there, but we might not get back down to the alarm level of below 60 in capacity again. This sump cover has an area there for the wires to go through. One is for the power. One of the holes is empty, right? Because there could have been a wire to come up to a switch. Some of the switches are above the tank, above the lid. So I had an empty hole. And I've just got my little monitor sitting over top of the empty hole. In fact, let me show you. Move that off, and then it's just loose. And right now it's going off because as we lose distance, let me see if I can film this. As we lose distance, the alarm starts going off. And my alarm is goofy. It's the tone of the alarm is driven by the distance. So as you lose distance, it goes down. So imagine that wave, that sound wave, right, is shooting through this little hole, which is partially blocked, by the way, and going down into the tank and reading the water level down in the tank. Everybody's experience with this is going to be different, right? Because what you're going to have to do is you're going to have to try to get it to read as deep as you can, and then you're going to have to sort of calibrate your meter up here. Your user interface is going to have, that's where you're going to set your alarm levels. So to try to understand some of these anomalies, some of the noisy readings that we're getting from the sensor shining down into the sump, thought I might try to draw a diagram of kind of the environment inside that inside that sump. The sump is pretty deep and tall, and basically it's a cylinder with a lid on top, and in that lid there's a hole where the sensor is shining down. All right, now let's say this is the cone of the sensor's sort of perception. So as you can see, there's going to be a lot of echo, right? The waves are going to come down and, you know, echo off the sides, hit the bottom, jump back up, and the sensor does a pretty good job of sort of trying to average everything that it's getting back, trying to average it out, or maybe even just taking the nearest, something like that. Let's also look at what else is in the environment, right? Down in the bottom there's a sump pump. Hard to tell, hard to know where exactly it's positioned in here, but it has, you know, a height like this and probably a pretty decent sized footprint in the bottom of that pump, in the bottom of that tank. Running up from it is a power cord. Probably not in a straight line or whatever, who knows exactly what it looks like, and it's coming up right in there beside that beam of light, or that the cone of the ultrasonic sensor's perception. And then there's water, right? There's water in the bottom of the tank at a certain level, and in an empty state, right, it's going to be probably below the top of the pump. And in an empty sort of steady state where nothing's happening, it's very flat. So this would be the environment, sort of when you're empty as you're going to get, right, and sort of nothing's happening. Now, this is where it starts getting a little more complicated. The pipe that water flows into the sump is raised, I don't know, probably at least a third from the bottom. So the water all comes in through a pipe that's up here. Now, depending on the flow rate of that water, probably, you know, how hard it's coming in, you know, it's going to shoot out here. Maybe a little bit, maybe it's going to be a little trickle sometimes, maybe it's going to be a hard push out sometimes and come out here like this. And of course, that's going to create turbulence in the water. And then, you know, as that continues, the water level is going to rise, you know, and probably maybe even come over the top of the pump. While that water is flowing, right, the cone is probably picking it up. It's probably sensing the water that's sort of in the air. And that is probably a good bit of the source of some of the turbulence that we see while water is flowing in. Now, what is the point of the sensor, right? What is the point of this monitor, this tank monitor? You know, we don't want this sump to overflow, right? So if the water gets that high, we've actually sort of removed all of the things that can cause turbulence, or, you know, sort of misinterpretations. Maybe the wire coming down, that's probably already factored in. So if it gets this high and we're detecting a reading, you know, of, who knows, maybe like this would be like 50 centimeters. Whereas our normal sort of empty tank reading, right, would be more like 70 centimeters, right, somewhere around in here, right. if we get to 50 centimeters, we've still got plenty of room, you know, to keep measuring, because this, you know, this ultrasonic sensor, it gets to the point where it won't measure anymore, I think, at distances of less than like 30 centimeters. At that point, we can't even read it. All through this region above the pipe and below where we can sense, right? All through that region right there, we're going to be able to sound an alarm. And I've changed the wrong colors, but all through this sensor, this area right here, we're going to be able to sound an alarm and let somebody know that, you know, the water is getting way too high, that the pump's not working. So I don't think we need to get terribly concerned. I've been out of shape, right, about some of the radical, if you want to call it, readings we're getting under normal operating conditions between, you know, bottom of pool and when the pump runs. Now the next thing I'm not going to worry about though is the power going to the sensor. You know, this pump is running off of a connection to the wall, connection to the mains, and I've got the sensor running off the same connection to the mains. So let's say the pump tripped the breaker. Well, it would also kill power to the sensor. So probably going to need, in our production environment, we would probably need some sort of a battery backup, and that battery backup needs to, you know, while it's in battery backup mode, it needs to be sitting there chirping an alarm saying, look, power's out to your pump. That's part of the genius of this, right, is you need to know that the power's out to your pump. Don't run any water. What was it? Oh, we also need to get it hooked up to where it's probably going to be able to communicate with some sort of automation service. Lots of ways to do that, right? It could basically just publish to an MQTT. We could probably set up Wi-Fi Manager, give Wi-Fi Manager some parameters so that it knows, oh yeah, okay, you want me to publish to this term or to this MQTT server, and every time there's a fluctuation of, and I'll be able to set, you know, a parameter that says what is the sensitivity level. You know, if the fluid level varies by more than 1, then send an update. You know, if it's sitting there very stable and calm and nothing's happening, it's not varying by more than 1 centimeter, then don't send an update. You know, don't post. That's all pretty simple stuff to, you know, code and get working. I would think there's an MQTT client for Arduino, so we got Wi-Fi. We're already using Wi-Fi, so it's really a pretty, especially with this little display, it's a pretty. I'll also need that same sensitivity level we need to use to control turning the display on. It doesn't need to sit there and burn all the time, right? That'll just burn it out eventually. It needs to come on when there's activity. It needs to send out, you know, notifications when there's an activity. And sound an alarm, you know, when the alarm level, the capacity is getting too low. So, yeah. I think that pretty much wraps this up. I hope the visual here helps. And, you know, the parts to do this are relatively cheap, and the software is relatively simple. And it can save you a lot of heartache and, I mean, damage. I mean, if the sump overflows and it gets your carpet wet or your hardwood wet, or it soaks into your drywall from below, you know, that's a lot of damage. It could save you a lot of money to have one of these little DIY sump pump monitors. Sump pump and sump monitors. All right, thanks. Sump pump just ran. Things seems relatively stable. Oh, I need to update. I need to update that uptime there. It's a negative number, so it went back in time. Yeah, that's a feature. That's a black hole. Time dilation going on. Actually, time dilation won't let you go back in time, will it? Must be a wormhole.